minus fx plus mod of fx minus L2. And what is mod of L1 minus fx? This is epsilon by 2. So this is epsilon by 2, and this is also epsilon 2. Okay, when mod of x minus a is less than delta, this implies mod of L1 minus L2 less than epsilon. Okay, when mod of x minus a less than delta. So since we have assumed that epsilon is very small number and the difference between L1 and L2 is very small as you wish. Okay, epsilon is very small. Okay, this may be near about 0. So then we can say that L1 is equal to, since epsilon is arbitrary arbitrarily arbitrarily small, then L1 must be L2, but we have assumed that L1 is not equal to L2. Okay, but we have proved that L1 equal to L2. That means our assumption is wrong. What we have assumed? We have assumed that L1 is not equal to L2 and the limit of this function is not unique. But we have shown that L1 is equal to L2. That means our assumption is wrong here. So what will be right? That means the limit is unique. Hence, limit x tending to a f of x is unique. Okay, do you understand? Any problem in this proof? Do you have any problem?
Sir,
Sorry. Okay, okay, okay. I have to prove that the limit of this function is unique. Okay, when the limit exists, then that limit must be unique. Okay, so let us first assume that this limit is not unique. Okay, so according to the definition of limit, epsilon delta definition, that limit L exists, that means mod of fx minus L less than epsilon when mod of x minus a less than delta. Okay, so to prove this one, we have used the contradictory method. That means first of all we assume that this is not true. Okay, then we have concluded with a contradiction. Okay, then we saw that the assumption is wrong. That means first we have to assume that limit of this function is not unique. So we have assumed that limit of this function is not unique. That means there must be at most two limits, at least two limits. So we assume that L1 and L2 are two limits of this function, and L1 is not equal to L2. So applying the epsilon delta definition of limit, we saw that mod of fx minus L1 less than epsilon by 2, and when mod x minus L less than delta, and similarly for L2. And our aim is to prove that this limit is unique. So we have written this mod of L1 minus L2 equal to this, and we just add and subtract fx to this one, and this must be mod of L1 minus fx plus mod of fx minus L2. And what is mod of fx minus L1? This is epsilon by 2, and this is also epsilon by 2, and this one gives mod of L1 minus L2 less than epsilon. Okay, and we assume that epsilon is very arbitrarily small. Okay, very small. So when the difference of these two numbers is very small, then we can say that this number is uh, not exactly equal. We can say that these are near about number. Okay, that means we can say that L1 equal to L2. Okay, but we assume that L1 not equal to L2. In the beginning we assume that L1 not equal to L2, but we have finishes with L1 equal to L2. That means our assumption is wrong. Understand? We have started by assuming that limit is not unique, but when we assume that limit is not unique, then there must be two limits, L1 and L2, and we assume that L1 is not equal to L2, but we concluded that L1 equal to L2. That means our assumption is wrong. That's why this is uh, occurred. Understand? That means our assumption is wrong. So our assumption is wrong. So our statement will be limit of this function is unique. Understand? Okay. Okay. Now there is a theorem for limit finding limit of functions. Okay. Like write down Sandwich theorem. Sandwich theorem. Okay, let's first tell me how many of you have eaten sandwich? Do you guys know the structure of sandwich?
यस सर,
यस सर।
स्ट्रक्चर तो जानता है, लेकिन खाया नहीं।
बताओ सैंडविच का स्ट्रक्चर कैसा होता है?
ऊपर एक बेड, नीचे एक बेड और
और बीच में कुछ होता है
बीच
ना?
में टमाटर, गाजर कुछ भी देते हैं।
हाँ, कुछ भी डालो, ठीक है। तो मतलब ऊपर भी होना चाहिए, बीच में भी नीचे होना चाहिए और बीच में भी कुछ होना चाहिए, यही बात है ना?
हाँ,
तो वो सैंडविच थ्योरम भी वैसा ही है, ठीक है। if there are three functions, okay, that means some functions are outside and some functions are inside. Okay, so the property of the function depends on the outsider functions. Okay, so write down if in a certain neighborhood of a f of x less than equal to gx, and this is less than equal to h of x, and limit x tending to a f of x equals to L equals to limit x tending to a h of x, then now can you say what will be the limit of gx?
सेम।
X tending to a gx must be L. Okay, so this is the beauty of Sandwich theorem. Okay, that if we know the limit of these two outside function, then we can say the limit of this function. Okay, so if fx less than equal to gx and less than equal to hx, and limit of fx and gx is hx is L, then limit of gx must be L. Okay, so we have an example for this theorem. Okay, so that limit x tending to 0, x sine 1 by x. Can you say what will be the limit of this?
0, sir.
How?
Sir, it will be like
Without any theorem, applying any theorem, can you say what will be the limit?
Sir,
How this limit will be 0? Okay, without applying any theorem or applying Sandys theorem.
sir, one. Sir, one.
How? How this will be 1?
Uh, Sir, sin 1 by x by 1 by x তো যে সূত্র হচ্ছে
That
1
theorem, that theorems will be applied when x tending to 0 and x is sin x upon x. Okay,
yes, it will be 0, sir.
and this is x and sine 1 by x. So this is not defined at x equal to 0. Okay, so can you say that x tending to 0 and this is sine 1 by x? Okay, and we know that sine x is a function which range is -1 to 1. Okay, so whatever will be the value of x, sin x never goes to infinity. Understand?
Yes, sir.
The value of range of sine is what? -1 to 1.
Yes,
Okay, and if we apply product formula here, that means limit x tends to 0 and limit x into these are two functions, fx and gx. Assume that f x is gx, then what will be limit? This is limit x tends to 0 x into limit x tends to 0 sine 1 by x, and
yes,
sine 1 by x is inside -1 to 1. Okay, always. That means this sine 1 by x is always bounded, okay, in 1 to 1. So x tending to 0 and some constant or some bounded number must be 0.
yes.
Okay, so this is limit equal to 0. Okay, now apply Sandys theorem. How can you prove this by applying Sandys theorem? Can you prove this one by applying Sandys theorem? So let's do. Uh, what is our goal? Our goal is to find fx and hx. Then we can say about gx. Okay.
Yes.
So first, what do we know? We know the range of sine on x is -1 to 1. We know that -1 less than equal to sine 1 upon x less than equal to 1. Okay. Now we can multiply by x in both sides. That means x minus x less than equal to sine 1 upon this is also x and this is less than equal to x. Okay, so now can we apply limit here? Now limit x tending to 0 minus x less than equal to limit x sine 1 upon x and less than equal to limit x tending to 0, and this is also extending to 0. And what is the limit of this one? Limit x tends to 0 minus x is 0 and limit x tends to 0 x is also 0. So limit of fx is 0, limit of hx is 0. So what will be the
0.
limit of gx? This is also 0. So applying sandwich theorem, we can say limit x tending to 0 x sine 1 upon x equal to 0. Understand? Okay, any doubts? So do you have any doubt in limit? Then we'll start continuity. Okay, so let's start continuity. So okay, so continuity means there is no break in any function. Okay, that means when we say that a function is continuous, uh, if limit x tending to a, f of x equal to f of a. This is the definition of a formal continuous function. Okay, that means limit of function is also equals to at the value of the function. This is the basic definition of limit, which you have read in your 12th standard. Okay, now we'll introduce a new kind of definition of limit. Okay, that is epsilon delta definition. Okay, so definition write down. Okay, let f from D is a domain and domain is from a real number, so to R. Okay, be a function, be any function. Okay, then f is said to be continuous at a point, then f is said to be continuous at some point, say C belongs to or A belongs to the domain. Okay, if for epsilon greater than 0 there exist, okay, this is there exist, okay, there exist a delta greater than 0 such that mod of fx mod of fx minus fc less than epsilon whenever mod of x, sorry, this is a mod of fa x minus a less than delta. So just understand the definition of this one and then try to understand the epsilon delta definition. This definition tells us that when x approaches some point a, okay, and this limiting value is equal to exactly at that point. Okay, but in you can say that if this one is a function, okay, graphically, like say that this is some function, okay, fx, and you have to say that this fx is continuous and at some point say this is a, okay, some point a. So then whatever what is this one, you can say that draw this line and also draw some line here. Okay, like this one is x minus a and this was in x plus a. Okay, sorry, a plus delta, a minus delta, and this is a plus delta. This is mod of x minus a less than delta. So x is ranging from a minus delta to this is a, and fx is continuous in this point. That means if I have f of a and this is f of x, that difference between this function fx and this fa, and this is f of a plus epsilon, and this is f of a minus epsilon. That means when this point moves left or right sometimes, then this fa and fa is also moves a little bit, okay, but this difference is very small. That means when this point a approaches, this function is also approaches, but this epsilon is very small, so there is no break. Okay, since this epsilon is very small, what, how can we assume that we can assume 1 upon 10 lakh, 1 upon 10 to the power 10? How can we assume? Okay, हम जितना भी assume कर सकते हैं, जितना भी छोटा से छोटा हो, ठीक है, उसको हम assume कर सकते हैं यहाँ पे, ठीक है. So that means there is no break in this function. Okay, if this is a function and we have assumed that this function is continuous at a point, then epsilon delta definition tells us that the difference of fx and fa is very small in the neighborhood of a. Okay, since epsilon is very small, so that means in this region there is no break in the function. Okay, so this is the definition, epsilon delta definition of continuous function. Okay, understand? Any doubt? किसी को कोई डाउट है इसमें? Okay, then do an basic example. Okay, prove that prove that f of x equal to x belongs to R is continuous on R. Okay, we have uh, we have written a definition of continuity at a point A, but uh, when we can say that this function fx is continuous in a whole set, this function is continuous in whole set when the function is continuous at every point of the set. Okay, so in this example we have to say that fx equal to x when x is real number is continuous on R. Okay, so using the epsilon delta definition, so write down the solution. Let c let a belongs to R be any real number, then mod of fx minus f of a equal to x minus a. Okay, now let us choose an epsilon. Let us choose epsilon greater than 0, then mod of fx minus f of a equals to mod of x minus a less than epsilon, when mod of x minus a less than epsilon. This is mod of x minus a, and x minus a less than epsilon, and this is also mod of x minus a less than epsilon, and that is mod of x fx minus f of a less than epsilon when mod of x minus a less than delta, where this delta equal to epsilon. We have chosen delta equals to epsilon. That means delta depends on this epsilon. Okay. Now we have to prove that this fx is continuous in R. and we have proved that fx is continuous at a point a belongs to R. But since a is arbitrary, okay, so f of x is continuous at x equal to a. But a is a real number and which is arbitrary. Since a is arbitrary, so fx is continuous on R. Okay, understand?
Sir, can you see me in last page?
Last page. Okay, tell me. So we have to prove that fx equal to x is continuous on R. Okay, and according to the definition, f is continuous at a point if mod of fx minus fl less than epsilon. For epsilon greater than 0, there exists delta. That means epsilon delta depends on epsilon. Okay, delta depends on epsilon. If for epsilon greater than 0 there exists a delta, that means this delta depends on epsilon. Okay, so according to the definition, we assume that a belongs to R, and we have to prove that this function fx is continuous at R. That means mod of fx minus fa less than epsilon for some delta. So mod of fx minus fa is what? Mod of x minus a, since fx is x. Okay, so this is our assumption, and let us choose epsilon greater than 0. Then what will be our aim? Our aim is to show that mod of fx minus fa less than epsilon, and we have to find such delta, okay, for which if mod of x minus a less than delta. Okay, so this is mod of fx minus fa, and this one is mod of x minus a, and this is less than epsilon. And since this is less than epsilon, so we have chosen delta equals to epsilon, and so mod of fx minus fa less than epsilon when mod of x minus a less than delta, and this is our goal. That means this fx is continuous at a point a, and we have to prove that this fx is continuous on R. And since a is a arbitrary number, a is an arbitrary number, so we can say that this fx is continuous on the set R. Okay, understand?
Sir, we got the epsilon.
Yes,
Fx minus fa, mod of fx minus fa equals to mod of x minus a.
yes.
Uh, that is the value we assuming that epsilon is greater than that.
Epsilon is greater than 0. Okay, and we
Yes.
have to show that mod of fx minus fa is hot if this one is mod of, not x, this one is x square. Okay,
Yes.
let's understand, if fx is x square. Okay,
Okay.
then what will be mod of fx, and we will try to prove
Square
this
minus
function mod of f of x minus f of a
a
will be
equals
what? Mod of x
x square minus x square.
square minus a square.
Yes.
Okay, that means this one is what? Mod of x plus a and
Yes.
mod of x minus a, this one.
Okay. Yes.
Okay, and also you can write this one as mod of x plus a and mod of x minus a.
Okay.
Okay,
Yes.
this one.
It
But our aim is to prove that mod of fx minus fa less than epsilon. Okay, that
yes.
means this whole on is less than epsilon.
Yes.
Okay,
Yes.
so now this x is here. Okay, so
Yes.
we can choose some delta like that, this whole term mod of x minus a, and our aim is to choose such delta that mod of x minus a less than
Yes.
delta.
Yes.
Okay, then when this one will be delta, how this epsilon and delta will be related? Okay,
Yes.
how can we choose this delta? How can we choose this delta? Can you tell me? This
It.
whole one is less than epsilon, and this that from here we can say that mod of x minus a less than epsilon upon mod of x plus a, and this is the possibility.
Yes.
Okay, and we have to choose such delta that mod of x minus a less than delta. That means this term is equal to a delta.
Yes. Yes.
Understand? That means epsilon upon mod of x plus a, this term is delta.
Yes.
Understand? Then we can say that mod of x minus a less than delta, where delta equal to epsilon upon mod of
Epsilon.
x
Mod
plus
of
a.
x. Yes.
So this delta depends on this epsilon and also this point x. Okay,
Yes.
that's why we have chosen this one. Okay, that means we have to find such a delta according to that epsilon. Okay, epsilon does not depends on delta, but this delta forcefully depends on this epsilon. Okay,
Okay. Okay.
so in this case, since our function is a very simple function fx equal to x, then this
Yes.
is no problem. Okay,
No.
also you can understand from fx equal to sin x or fx equal to cos x. Okay, then what is the fx minus f of a? This is
Sin.
mod of sin x minus sin a.
Yes.
Okay, and sin c minus sin d, what is sin x sin c minus sin d?
2 sin c plus d by 2.
2 sin c plus d by 2, that means x plus a upon 2, and next one sin c
C
minus sin
minus
d,
D.
cos c minus d by 2.
cos c minus d by 2, and this one that means x minus a upon 2. Okay, and what is this is product function, and mod of sin x is less than equal to 1. So can we write this one as this is a product function? Okay, so less than equal to 2 times, and cos theta is what? Mod of cos theta less than equal to theta.
Yes.
Okay, that means we can write this one as x minus a upon 2, and this 2 one is cancel out. Okay,
Yes. Yeah.
so then we can write that this one is less than equal to mod of x minus a. Okay, so mod of fx minus fa is less than equal to mod of x minus, and this is less than epsilon, and in this case also epsilon equal to delta whenever mod of x minus a less than delta. Understand? So that's how we have to find out our delta. Okay, now write down some basic properties of continuous function. Okay, properties of continuous functions. Okay, let f and g be two functions which are continuous. Let f comma g from D contain in R to R to continuous functions, then number 1, sum of these two functions f of f plus g is continuous. Similar properties for the limit. Okay,
Okay.
continuous. Number 2, if k belongs to some real number, then the scalar product of function is also continuous. It's continuous. Okay. The product of any two continuous function is also continuous. F into g is continuous. Okay. And number 4, if f upon g is continuous when never, what will be the condition?
Sir, gx
Fx,
not is equal to 0.
yes, exactly. Whenever gx is not equal to 0 for all x belongs to d. Okay, so the ratio of fx and gx is continuous provided gx is not equal to 0 in the domain. Okay, so write down a theorem. These all are properties of a continuous functions. Okay, this is algebra. Write down a theorem called let f from d contain in R to R be continuous on D, then mod of f is also continuous. But what about the converse of this theorem? We say that if a function fx is continuous, then the modulus of that function is also continuous. But what about the modulus? If modulus is continuous, then can we say that f is also continuous?
Hmm.
बता सकते हो क्या कोई?
No, sir.
Can you give an example? A function fx is continuous, then mod f is also continuous. But we have to show that, but the converse, this is a theorem and this is a note, but the converse is not always true. Sometimes it may be true or may not be true. Okay. For example, fx equal to 1 when x belongs to some rational number and equal to -1 when x belongs to what? Some irrational number. Okay. So this is fx, and fx is 1 when x belongs to q and -1 when x belongs to irrational number. And what is the modulus of fx? What is modulus of fx?
It's will be 1.
Modulus of fx is 1, and 1 is what? Constant function.
Yes.
This implies if mod of fx is continuous, but is fx continuous?
There is
Okay,
two
but
value.
but in fx is rational 1 when x is q and -1 when x belongs to c. that means the limit of this function is either 1 or -1. That means this limit is not unique.
Yes.
Okay,
That
so that means this fx is not a continuous function, but modulus of fx is continuous. Okay, but f of x is not continuous. Okay, so any problem?
सर वो सिंबल नहीं समझ में आया सर, जो फंक्शन है
Sorry,
एफ फ्रॉम डी सबसेट आर है क्या?
d is a domain and this is a subset of r, real number, set of real number.
अच्छा सर जी.
Okay, now write down another theorem, the composite property of a continuous function. Okay, let in your syllabus only statements are there. Okay, the proofs are not in your course. Okay, f from a to r be continuous on a and g from b to r be continuous on b and f of a is contained in b, then this theorem tells us that the composite then the composite function g of f, what will be the domain of g of f? What will
सर
be the
ए
domain of? Okay,
ए
from a to r is continuous on, what will be the set? fx is continuous on a, gx is continuous on b, and fa is contained b, and g of f is from a to r. Then what is the domain where g of f is continuous? In which set?
it's a set.
Yes. Then g of f is continuous on set A. Okay. So this is the property of a continuous function when fx and gx are in composite form. Okay. So for example, write fx equal to sin x when x belongs to 0 to pi and gx equal to log x and x. What is the domain of log x?
Domain, sir, it's
What is the domain of log x?
1 to infinity.
On to infinity. X greater than 0.
Yes.
Okay.
Yes.
Then what is the composition of this function? What is g of f? What is g of fx?
Log
सर
sin
लॉग
x.
लॉग
Okay. Log of sin x. Okay. That means so log of sin x is a composite function. Okay. And fx is continuous on 0 to pi and gx is continuous on the domain x greater than 0. So log of sin x is continuous on which set?
0 to pi.
Okay. then g of f is continuous on 0 to pi. Okay, so now write down some basic properties of continuous function on a closed interval. Okay, properties of continuous functions on closed interval. Theorem 1. Let a comma b be a closed and bounded interval and a function f from closed interval ab to r is continuous on this interval on I, then f is bounded on ab. Okay, but this theorem tells us that if f is continuous on a closed and bounded interval, then that function is also bounded on that interval. Understand? This theorem tells us that if a function is continuous on a closed and bounded interval, then that function is bounded on that interval. Okay, these are very important theorems. Okay, the next theorem, this is called Bolzano's theorem for a continuous function. Okay, let f from closed interval ab to r be a continuous function on AB. Now, if FA and FB are of opposite sign, then there exists at least a point C belongs to AB such that f of C equal to 0. Can you say what is the meaning of this theorem? This theorem tells us if fx is a continuous function on a closed interval, okay, and fa and fb are of opposite signs, then there exists at least a point in this interval such that f of c equal to 0. What is the meaning of this theorem? What is the meaning of this theorem?
So, example cites sin x if sin x there is 0 to pi range in
Yes,
closed interval.
yes.
There is fa like we get fa 0 f0 equals to 0 and fb it will be no
AB
0
is also 0.
yes fb was also
Okay.
sir.
What is the meaning of this one? Fx is continuous in this interval, and this theorem tells us that Fa and Fb are of opposite sign. Opposite sign meaning what?
1 and minus 1 that sign
Okay,
90.
and for a function, if function occurs opposite sign, that means what? What this tells us?
सर दोनों फंक्शन के बीच में एक तो क्रिटिकल पॉइंट होगा क्या?
What is critical point?
क्रिटिकल पॉइंट वो होगा जो लेफ्ट हैंड साइड मतलब निगेटिव, राइट अपोजिट मतलब ये
Sorry.
पॉजिटिव.
F of c equal to 0 means what? If fx is
It
a
means
function and if some
there is a
point,
there is a
okay,
point in between A and B which
okay.
what for f of c equals to that means
F of c equal to 0
it
tells us what is c. Then what is c? Just
a
1 minute.
point between
Just
A
1 minute.
and
Just 1 minute. Just 1 minute.
The point on x. Hello.
Sorry guys. हाँ बताओ. F of
you
c
just
equal to
ask
0 का क्या meaning है?
sir, you just ask what is C and C is the C is in between A and B point in point A
Okay, okay.
point.
Uh, no, I am asking that if fx is any function, okay, and
Okay,
at some point if f of c equal to 0, then
okay.
what is c?
C at a point on x-axis.
Okay, and x, if, you assume that fx is a polynomial. Okay, fx is a polynomial, any polynomial. Okay, and at some point p of c equal to 0, then what is this c? No, you this c is a roots of that polynomial. Okay,
Okay, sir.
if 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 px is a polynomial like that, x cube plus x square plus x plus 1, this is a polynomial. Okay, this is a polynomial. I say that fx px equal to x cube plus x square plus x plus 1 equal to 0. This is a polynomial, any polynomial I assumed. Okay, then if you say that if px has a roots, then what will you say? That I assume that 1 is a roots of the polynomial. That means p of 1 equal to 0. This is the property of a root. Okay, got it? Okay, so what this theorem tells us?
Sir, what is the meaning of 1 hour? Why are we writing 1 hour?
Sorry.
Hello, sir.
Yes.
Sir, 1 hour क्यों लिखे?
One.
तो
ऊपर
रियल
में हेडिंग
नंबर
में
है।
लेट.
हाँ. Yes.
It's
तो
Because
रियल
this
रियल का
if
साइन
yes, we all things are done in real system. Okay, because the set which we assume here, the range of all these functions are in real. Okay, nothing to the complex system. Okay, we are working on a real system. Okay,
okay.
so the beauty of this theorem is that if f is continuous in this closed interval and fa and fb are of opposite sign, that means this fx changes its sign. Okay, f and fb are of opposite sign, that means what? This f of x is a function and this is of opposite sign, that means this fx somewhere changes sign.
Yes.
If this is a graph of a function, okay, this is a function, okay, and this is a function. When we say that this function is uh, above this x-axis, always this function is positive. Okay,
Yes.
always positive. And when this we say that this function changes its sign, when this function is negative, that means when this comes below this graph x-axis, that means fx, in this case positive and in this case negative. And what we have got in between, in
There is a
between we
point.
got a point. Okay, that means when a function changes its sign, we got at least one root of that function. Understand? This is what we have got in this theorem, but maybe more than one, but we can say that at least one. What is the meaning of at least? At least meanings at least
एक
one. Okay, मतलब इससे ज्यादा भी हो सकता है, लेकिन एक कम से कम एक तो मिलेगा ही.
Yes.
ठीक है ना? So this is the beauty of this Bolzano's theorem, that if f is a function which is continuous in this interval, then we can say that if between this point a and b there must exist at least one root of that function. Okay, when f and fb are of opposite sign. Okay, understand?
Yes.
Okay. Now next theorem tells us if
Like
f is continuous at a point C or A, at A, and f of A is not equal to 0. That means f is continuous at a point A, but f of A is non-zero. Okay, that means the function is not vanishing at that point. Okay, then there exists an interval C minus A minus delta to A plus delta around A such that f of x has the sine of f of a for every value of x in this interval. Okay, just try to understand this theorem. This theorem tells us if a function fx is continuous at some point, say like this, okay, that this is a function fx and this is a point a, and this is a f of a, okay, and this point is x equal to a, okay, and this function tells us that if fx is continuous and fa is non-zero, that means this uh, does not cut this x-axis, f of a not equal to 0, that means this function is not cuts the x-axis at x equal to a, okay, that means a is not the root of that function, okay, that means this function is always above the axis or below the axis, okay. So fa not equal to 0 means what? Fa is non-zero, that means at x equal to a, if x is a function and this is x-axis, then f of a is 0, that means this cuts the x-axis at x equal to a, but fa is non-zero, that means either this function is above the axis or below the axis, but never cuts the axis at x equal to a. This is the meaning of fa not equal to 0, okay. Then this tells us that there exists an interval a minus delta, okay, this is x equal to a, and I assume that this is x minus a minus delta, and assume that a plus delta, and this distance is delta and this distance is also delta, and interval a minus delta to a plus delta such that fx, that means this function fx, okay, has the same sign. What is the sign of fa? Okay, that means in a neighborhood of a point, okay, the sign of the continuous function is same as the sign of the function at that point, okay. If fx is any function, okay, say x cube, okay, and I will say that f of uh, minus 1 equal to what? Minus 1,
Yes.
okay, that means f of minus 1 is non-zero according to this property. This property holds here, that means f of minus 1 is non-zero, and this theorem tells us that if we assume that this is minus 1, okay, if you assume that in some neighborhood minus 1 and this is minus some delta and this is minus 1 plus some delta in this neighborhood, and this is a function x cube, then in this interval sign of this function is also same. That means if f of minus 1 is minus 1, that means this is negative, so in this neighborhood also this function fx is what? Negative. Understand? ये theorem को समझ में आया?
Yes.
Okay, that means what happened if this sign is not same, then
It cut the x-axis.
okay, yes, exactly. We have assumed that fa is non-zero, okay. Just see this in a graph. We have given that fa is non-zero, okay, and in graph if you see that this is a graph, okay, and if I say that this is a minus delta and this point is a plus delta, okay, and this is f of a, if at a minus delta some left neighborhood, if this is say at f a minus delta, in this case if this is less than 0 and in this case this is positive, that means in somewhere there this cuts the axis,
Yes.
okay, at x equal to a, but we have given that fa is non-zero. That means this that does not cut the axis at x equal to a. So this contradicts our assumption. That means the property of a continuous function is that if fx is continuous in a closed interval, then the sign of that function is always same in that neighborhood. Okay, so understand?
Yes, sir.
Okay. Now there are if there are continuity, then there are also some discontinuity. Is there every function continuous? There are
Yes.
lots of functions which are not continuous. Okay,
Yes, sir.
so discontinuity, if a function is not continuous, then if a function is not continuous, then it is discontinuous. Okay, so there are various kinds of discontinuity. Okay, so types of discontinuity. First one is what? Removable discontinuity. Removable discontinuity. The word removable tells you that if a function is discontinuous at some point, then you can remove that point and you can make the discontinuous function to continuous function. Okay, fx is said to have removable discontinuity if limit of fx exist, but limit x tending to a fx is not equal to f of a. Okay, so understand what is the removable discontinuity. That limit of this function exists, but the value of that limit is not equal to the limit of that function. Okay, then this type of limit is called removable discontinuity. Okay, and second type of discontinuity is discontinuity of first kind. Discontinuity of first kind. Okay, if limit x tends to a plus f of x is not equal to limit x tends to a minus f of x. What is the meaning of this definition?
left side limit and right side limit is true.
Okay.
Function in
In first case limit exists, but in second case limit does not exist. Okay. And left hand limit exists and right hand limit exists, but these two are not equal. That means our limit is not exist. Then this type of discontinuity is called discontinuity of first kind. Okay. Another example is another discontinuity of second kind. Okay. And what will be the possibility of other case? Neither if
The
neither of
left hand
limit x tending to a plus fx and limit x tending to a minus fx exist. So this is the discontinuity of second kind. Neither left hand limit or right hand limit are exist. But then this type of limit discontinuity is called second kind of discontinuity. Okay. Now we'll do some examples. Find the value of k for which the given function f of x equal to tan of pi by 4 plus x to the power 1 by x when x is not equal to 0 and when x equal to 0, find the value of a for which this function is continuous at x equal to 0. Okay, and this is your homework. You will do this in your own. Okay, can we solve this one? I'll just tell you to solve this one. First of all, you have to find the limit of the function, and since this function is continuous, then limit of the function is also equal to the value of the function. Okay, so can you solve this one? So just try to solve and find the value of k.
Okay, sir.
Okay.
Sir, could you please send today's note in the group?
Yes, yes.
Okay, thank you, sir.
I'll send you all of the notes. Okay.
Okay, sir.
So just try to solve this, and also I will give you some more examples. Okay, related to these results. Okay. So you'll try to solve the examples, and later on I will start differentiability and some examples related to continuity and limit. Okay, so just try to revise this all properties of limit and continuity, and try to solve some examples from the books also. Okay, so is any doubt in today's class?
which book?
Sorry.
कौन से बुक से सर?
Okay, book you can follow. I will tell you the book which one I've given you, Shanti Narayan book, or do you have any book, then you can use, okay, for differentiation or integration, you can use any book, okay.
सर क्लास 12th का तो बुक जो था तो उसको यूज कर सकते
नहीं
हैं
नहीं,
जीके वैली
क्लास
का
12 का जो है वो बेसिक
यार
का
12th
है,
का
ठीक है। वो अभी बीएससी लेवल का जो है ना वो सब बुक यूज करने की कोशिश करो, ठीक है। 12th का तुम यूज कर सकते
सर
हो उसका बेसिक्स थोड़ा क्लियर करने के लिए, ठीक है।
सर बीवी रमन्ना बुक कैसा है वो, बीवी रमन्ना?
बीबी रमन मतलब किसका, 12th का है या ग्रेजुएट का है?
सर ग्रेजुएट का, मैथ्स का,
हम्म, देखो
इंजीनियरिंग का।
ज्यादा ज्यादा इतना बुक पढ़ने की जरूरत नहीं है, ठीक है। जो थियोरी वगैरह कराया जा रहा है वो सब पढ़ो, ठीक है।
सर
और
पढ़ने नहीं
बाकी
बोल रहे, उसे क्वेश्चन
हाँ,
सॉल्व करने के लिए।
क्वेश्चंस वगैरह सॉल्व करो थोड़ा थोड़ा करके, और क्वेश्चन मैं तुम लोगों को देता रहूंगा बीच में, ठीक है। वो सब क्वेश्चन सॉल्व करने की कोशिश करना।
सर आज सर आज मैथ्स का सेकंड क्लास ही है ना
हाँ, सेकंड
सर?
क्लास ही है आज,
हाँ
ठीक है। तो अभी तुम लोगों का एग्जाम कब होगा कुछ बताया क्या?
8 तारीख से तो सर डेट दिया है।
सर मार्च में सर।
मार्च में? अच्छा, मतलब फरवरी में ही क्लास चलेगा बस।
28
चलो, हाँ तो ज्यादा खींचना पड़ेगा, तुम लोग भी थोड़ा तैयार रहना, टाइम बहुत शॉर्ट है ना, तो
और सर आपका वो जो 20 नंबर होता है वो कैसे लेंगे?